Listen up, please. Listen. I can't start while there's people talking. I'm literally waiting for you. Be quiet. No, stop talking. Be quiet. All right. And I'm waiting for you guys as well. Come on. All right. Now, thank you. So we'll get started. Last time we were looking at solving and sketching cubics, and previous to that we did solving quadratics and solving linear. So what we're going to have a look at this morning is how to solve one linear and one quadratic. So there's nothing too special going on here. It's just a particular type of problem we need to have a look at. And that type of problem is something like this. And I'll do a few examples to get us going. So y equals 3x plus 13. And then y equals minus x squared minus 7x minus 8. So actually for solving these types of problems, unlike the simultaneous, we don't have a choice of methods. There really is only one method we can use here. I wonder if anyone knows what that method is. It's just a substitution. Yeah, because if you look carefully and think about this, it's this is equal to y, and we have a y here. So we can replace this y with this y, because after all they're the same, and this y is the same as this guy. So it's really just a case of putting that in here for y. So you'll get this equation, 3x plus 13. I'll just make these stars. 3x plus 13 equals minus x squared minus 7x minus 8. Well, this isn't so bad. If I take everything over to the left, I get x squared, 7x and 3x is 10x. 13 and 8 is 21, isn't it? Yeah. Equals 0. And this guy isn't so bad because this is just a quadratic with roots of 7 and 3. Yeah. So you might say, okay, x equals minus 3 or x equals minus 7, and you're finished. A very common mistake is students forget to get the y values. Okay, they forget to get the y value, so we still need to get the y's. So I think the easiest equation to use would be this one, yeah? So if you make x equals minus 3, we get 3 by minus 3 is minus 9, minus 9 plus 13 is 4, isn't it? And then minus 7, 3 times minus 7 is minus 21, minus 21 plus 13, what's that, minus 8? Okay, so there are two answers, either that or that. Now, why are the two answers? Well, we can finish the question off by doing a quick sketch. So, a very quick sketch here. There's x, there's y. Here's the linear equation. Crosses there at 13. Minus 3 minus 4, so minus 3, 4 would be something like here, and then minus 7 minus 8 would be something like here. So what's happening is okay, that there is minus 8. This point here is minus 3. No, it's not. Sorry, rewind. Oh, it's because my line is so bad. Here and here. Oh, japers. Okay. Right, that's minus 8. That first, that one there is minus 7. Oh, I'm too tired to draw this properly. It crosses twice, is my point here. Actually, do you know what, why am I trying? I've got a perfectly good computer here to do it for me. Right, anyways, write that down and I'll get a pretty picture for you. Okay. Do you have that written down? So that guy's ugly. He's not going to win any competition. Right, let's have a look at it here. What was my first equation, the quadratic? Y equals 3x plus 13 and y equals minus x squared
minus 7x
minus 7x
minus 8.
minus 8. Okay, let's see if I can draw the two together. Ah, there we go. That's beautiful. Alright, let me zoom in a little bit for you. So can you see here, what is that? Minus 3, 4, there it is there, can you see?
No.
Oh, sorry. There you go. You see there, minus 3, 4. Yeah? And what was the other one? Minus 7, minus 8. There it is there. This is where the two meet. Yeah? Now, let's do another one. And I'll keep this graphing program open. So, that's why we had two answers, because we have a picture like this. But I hope you realize we're not guaranteed two answers. I mean, we could have a situation like this. That would only be one answer. And is it possible that they don't meet? Yeah. You know, you could have something like this. Yeah? This isn't really the case with the simultaneous, because when you draw two lines, they usually meet somewhere, with only one exception. What's the only exception to the lines meeting? Parallel, yeah. As long as the lines aren't parallel, they'll eventually meet. Okay? So I've just done an example with two solutions. Now let's have a look at another one. Okay, let's try this one. Y equals 3x minus 11 and y equals 3x squared minus 3x minus 8. So again, make them equal. That's 3x minus 11 equals 3x squared minus 3x minus 8. So that's 3x squared minus 6x. 3 plus 3, isn't it? If I take everything to the right. Yeah? What should I do next? Before factorizing.
I'll take out 3.
Take out 3, yeah. Now I can factorize. What are my two factors here?
Minus y minus
Yeah? Or in other words, if you want, it's like that. So there's actually only one solution here. X equals 1. If I put that back in here, 3 minus 11 is minus 8?
Yeah.
So how does this look? Let me try this carefully. X, Y, steady. Thank you. Oh, thanks. One. Oh, actually, yeah, it's nice. It's like this. This is 1 minus 8. Yeah? It only meets once at 1 minus 8. I wonder if I can get a nicer one here. Let's see. Okay, if you can write that down. I'll just quickly flash up the nicer looking graph. Can you see? 1 minus 8. Yeah? Isn't it? There's 10. Yeah, roughly. Okay, so finish writing that one down, please. Yeah.
How can we use the way we stated this for the last graph and
Oh, my last graph was screwed up. That's why I destroyed it. I could use the intercept here. The intercept's also minus 8. And can you see here, the y-intercept is minus 11. I drew my graph way too small to try and pick that up.
Sorry, what number is exactly at 2 numbers in which the quadratic, the curve?
Yeah, it's... Oh, these two numbers?
Yeah.
I don't know what they are. We weren't asked for it.
So how do you know exactly where you, like when you bring the curve, how do you know?
The sketch.
It's just a sketch, yeah. The only
So
thing...
all you're aiming for is the y, that's the negative h which you put on top.
Oh no, all we're aiming for is where they meet. I just want a sketch of what it looks like. So is it meeting once? Is it meeting twice? That's all I'm trying to show. Do you know, I just want you to see that there's a difference between this problem, which has 2 answers, and this one which has 1 answer, and this one here which has no answers. That's all. That's the only reason I'm drawing a sketch. Because you might be wondering, why do I have only 1 answer here, whereas previously I had 2? Well, it's because this is a very special line. What's this line called, actually, when it meets once?
Tangent?
Tangent, yeah. When it meets twice? No. What do you call it if it meets twice? You all knew, a lot of you knew tangent, so what's the other one called? It meets twice.
Quadratic.
Cotangent, nice, I like it. Untangent, maybe. Antitangent. Anything else? Retangent? Cotangent? Cosine? Cosine, no good. No. Not sine either. Nobody? Intersect? No. If it meets twice, it's called secant. Although now that I made it up, I do kind of prefer antitangent, perhaps. All right, let's have a look at another one now. I'll give you one to try just to make sure you got the idea here. I'll just make it a tiny bit different. Can I scroll down? Okay. Solve and give a quick sketch. Okay, so the equation I shall give you is x plus y minus 11 equals 0, and then 2x squared minus 7x minus 3 plus y equals 0. 2x squared minus 7x minus 3 plus y equals 0, and x plus y minus 11 equals 0. I want you to try and solve this. I just made it a tiny bit more difficult, just to give you a little help, but I think a lot of you can see this. You need to rearrange the first one before you can start. So, what's the expression here? What do we call it? Or how do we say to rearrange it? So the hint, make y the subject, yeah. Okay, try that. Thank you. Right, I'm sure some people are finished now, so let's have a look at this one. So if I rearrange this fella, I get y equals minus x plus 11, yeah? Where I take the other 2 over to the right. And if I rearrange this guy, I get y equals minus 2x squared plus 7x plus 3. And I can make them equal. Minus x plus 11 equals minus 2x squared plus 7x plus 3. I shall take everything to the left. 2x squared minus 8x, 11 minus 3 is 8, isn't it? Alright, I should, what? Take out the 2, yeah. X squared minus 4x plus 4 equals 0? 2 and 2? Minus 2 and minus 2. So that means x equals 2 and y equals, let's see, yeah, minus 2 plus 11 is 9. That's the answer there. Okay. Oh yeah, and I said a quick sketch as well. So, okay. Let me think. 2, 9. So I'll put that there. There's x. There's y. Okay, and this fella. My line is going down, I think, because it's going down. And my quadratic is upside down. So like this. Whereas this point here is 3, and this point here is 11. Yes, 11. Okay, now that's a pretty good sketch. Okay, so it meets only once here. Yeah. Okay, can I scroll down? Yes? Okay. Right, another example to do. A little bit different now. 2x plus 7y plus 20 equals 0. Minus 2x squared plus xy plus 3y squared equals 0. Yeah, this one's a little bit different, but it's the same idea. I still need to make y the subject. So if I take this one here and make y the subject, what will I get? I'll get 7y equals minus 2x minus 20. So y equals minus 2 over 7x minus 20 over 7. But there's a little bit of a problem with the second equation. Can I make y the subject in the second one? I can't really. Yeah?
I think you can. Maybe if you take 2x to the other side, take y as common.
Yeah, but the problem is you'll be left with a y when you take the y out. You'll still have y twice.
But then you divide. Then you divide on both sides. That will cancel out, and then you just take the x to the other side.
No, let's see. 3x squared, you're saying do this, equals 2x squared, yeah? So then take out the y. So that's 3y plus 2 equals 2x squared. Now what's next?
You divide by y.
Okay, so then the y is over here. Yeah.
And then you take 2 to the other side.
This 2?
No, that.
Okay.
And then you divide by 3.
Okay, but you have y on both. You still have both, yeah. I know, I told you it wouldn't work. So, that's my point. Can we make y the subject? No.
Divided by xy.
No, all we'll do is, in this equation, where we see y, we'll just replace it with this. Yeah? because this is equal to y. So those two appearances of y get replaced by this expression in x. So now I have minus 2x squared plus xy, and y is minus 2 over 7x minus 20 over 7, close, plus 3y, which is minus 2 over 7x minus 20 over 7 squared equals 0. Can you see what? It's a substitution. I've replaced the y in the second equation with this. So it's a replacement, a substitution. Yeah?
Now we equate.
Well, now we have to expand them and simplify. Yeah? Okay. So we have a little bit of a problem because we have fractions here. Let's scroll down a bit. Can I scroll down? Yeah? Right, now just please make sure I don't make a mistake with my numbers because there's fractions here. So, expanding, I get minus 2x squared minus 2x squared over 7 minus 20 over 7x. Or 12 over 49x squared. Oh. Or 4 times 20 is 80. 240 minus minus plus 240 over 49x. 400 over 160. What's it?
Why is minus 12 over 49?
Where? Which one?
2 squared is 4.
Yeah.
4 times 3 is 12, no minus 12.
12. Oh, so that's a plus. Thank you.
You put minus in here.
Okay, so it'll be a plus. No, but I had a minus. I should have a plus, right? Because I squared it, yeah. Okay, this one's right, the next one, isn't it?
Yeah.
And then the last one is 400 to 1200 over 49?
400, yeah.
Or did you actually check? Or that wasn't a convincing yet. I was like, yeah. Is it?
Yeah, it is.
Okay. That's a bit of a pain. What should I do next to clean this guy up?
Multiply by 49.
Yeah, multiply by 49. So if I multiply by 49, that will be minus 98x squared minus 14x squared 7 minus 140x plus 12x squared plus 240x plus 1200 equals 0. Alright, now the fractions are gone, so I can group together. 12x squared plus 98x squared is 110x squared minus 14x squared is 96x squared. 240x minus 140x is 100x, right? Plus 1200. Is that right? I feel like I added something wrong there.
That's what you would have minus 2x squared, so that's minus 100x squared.
It's minus 100, is it?
Yeah.
Oh, sorry, yeah, thank you. Minus 100 x squared. Alright, I think it's pretty clear what I should divide by. Yeah, I should divide by minus 100. So I get x squared minus x minus 12 equals 0. Let me just write that again. It looks a little bit. I'll just write this little bit here. Minus 100. Okay. Minus x minus 4 x plus 3 equals 0. So I get x equals 4 or minus 3. Now, what's the best way to get the y? That's by using, well, I can only use this one, isn't it? Minus 8 over 7 minus 20 over 7, right? Minus 28 over 7. I put 4 in. Minus 8 over 7. Minus 28 over 7, is it? Yeah, so minus 4. Yeah, okay. Minus 6 over 7. No, that's a plus. Plus 6 over 7. 2? Is that right? Minus 2 something? Minus 2? If I put minus 3 in here, 6 sevenths minus 20 sevenths is minus 14 sevenths. Yeah, minus 2. So there are the two answers there. This is trickier for sure. This is more interesting than the last one, for sure. Now, I want to do this one again, but what's good about this question, yeah, this looks very messy, but there actually is another way you can do this which is a little bit neater. So let's have a look at the other way to do it once you're ready. Can I scroll? No? Yeah? Yes? This one, believe it or not, the sketch of this one is not on the syllabus because it's not actually the shape as the previous one was. If you're really curious, what actually you have here is something that looks like an ellipse intersecting a line. But this is not part of the course, so. Alright, can I scroll? Right. I want to show you another way to do this. I could rewrite this a different way. I could say this is 2x plus 7y equals minus 20. And actually, if you look really, really carefully, it's not, well, not quite that it's a perfect square or a completed square, but it's still a quadratic. So maybe you could factorize it. So you need to get minus 2x squared at the front. So maybe that makes you think you should use a minus 2x and an x, because that will make minus 2x squared at the front, right? What could I do to make a 3y squared at the back? I would need a 3y and a y. So I could put a 3y here and a y here. Now I need a plus xy in the middle. So how much is this? This is minus 2xy. And how much is this? 3xy. And when I add them together, what do I get? Yeah, which is exactly what I need. So I can actually factorize that. Now you might say, well, what's the point in factorizing that? Well, it makes you realize that this can be written two different ways. You can say 2x plus 7y equals minus 20, and minus 2x plus 3y must equal 0. Why am I saying this? Well, because here they multiply to make 0. But then you realize, but there's a second possibility. Or you could have 2x plus 7y equals minus 20, and x plus y equals 0. Now this is interesting because we have two possibilities, we'll have two answers, which is exactly what you expect, because previously, when we did this, we got two answers. So let's see if we get the same answers. So let's solve this one. What would be the easiest thing to do? I could multiply this by 2, couldn't I? So that's a 2 and that's a 2. I subtract, I get 5y equals minus 20 and y equals minus 4. If I sub that back in, I'll get x equals 4. Does that answer look familiar? Yeah, it was the second answer. Oh, look, this one's even nicer. I'll just directly add them together. So what do I get here? 10y equals 20. So what does y equal? 2. If I put 2 in here, I get 3. Is it for x? 3. So my answers are 3, 2, and 4 minus 4. What was my answers previously? Oh, did I have the wrong first answer? Oh, sorry, that was a minus. No, why is it minus 20? That was 20. Oh, sorry, minus 20. I didn't see this guy. Minus, sorry. Minus. So that means it's minus 2. Does that change my x? Let's see. To what? 4. Okay, let's just fix it up. Alright, y is minus 2, so that's minus 6 plus 6 divided by minus 2, minus 3, yeah? Minus 3. So it's minus 3 and minus 2. Are these the answers matching the previous one?
Yes.
Good, okay. Minus 2. Now, I think you agree that this method is easier.
Yes.
But there's one condition. The condition is, to use this method, you must be able to factorize this. Yeah? You must be able to factorize it. If you can factorize it, you can use a method like this. Yeah? So if you can just write this as an alternative method down. Okay, did you say yet? Have we got this? Is that a yes, no? Which part are you at now? Okay. Well, anyway, no more examples that I need to do. So you can get a start. AI and AG. Got it now? I can close this? Yeah, yeah.